In this video, I am going to discuss Mathematics Mechanics M1 Edexcel IAL past paper May 2022. Okay, the first question based on momentum. Edexcel IAL Mathematics Mechanics M1 May 2022, May-June 2022. First question. Two particles P and Q are moving towards each other in opposite directions along the same straight line, and when they collide directly, immediately before the collision, the speed of Q is 2u and the mass of Q is 3m, and the magnitude of impulse exerted by P on Q in the collision is 4mu. You know the impulse means that's from Newton's second law. We can start like this. Newton's second law says F equal ma, that is A equal B minus u, change in velocity over time, cross multiply Ft is equal to mv minus mu. Here Ft is called impulse. So impulse of one object or impulse experienced by one object is equal to change in momentum of the object. You know impulse is a vector quantity because force is a vector quantity, time is a scalar quantity. When you multiply a vector which is force by a scalar which is time, you will get a vector. So always change in momentum is a vector. The direction of the vector is along the direction of the force that changed the momentum. For example, if two objects are moving towards right, so imagine object A, before collision its velocity is u1, the other one, object B, it's moving towards right, this is moving towards left, velocity u2. So this mass is m1, this mass is m2. This is just before collision. During collision, what happens? The object A and object B, they are going to exert force on each other. The force exerted by A on B, if it is this direction F, then the force exerted by B on A will be towards left. Both will have the same magnitude of force according to Newton's third law. When object A exerts force on object B, that is denoted by F2 if I put it, then the object B will exert same magnitude of force on A towards left, that is F1 equal to F2. Both will have the same magnitude in opposite direction. So rather than writing F1, F2, I can say FF. Both will have the same magnitude of force. Okay, after collision, the object A might move towards left or right. B also could move on left or right, whatever it is. During collision, there is a change in momentum. Due to the change in momentum, there will be impulse. So the direction of the impulse experienced by A during collision will be towards left, or I can say the direction of change in momentum of A will be towards left according to this diagram, because A is experiencing force towards left. So Ft is mv minus mu, that is impulse. F is a vector. For A, F is towards left. Therefore, impulse on A is towards left. Same way, during collision, B also having change in momentum. It also experiencing impulse. That impulse is Ft. So the direction of the Ft, the impulse on B is towards right, because B is experiencing force towards right. Therefore, change in momentum of B or impulse of B should be towards right. And already I told that both will have the same magnitude of force according to Newton's third law. One of the properties of Newton's third law pair of force, that is third law pair of force, means A is exerting force on B, then B is exerting force on A. Both exerts force on each other during the same time. So the time also will be the same for both. The time duration A experiences the force will be same as the time duration B experiences force. Therefore, both will have the same magnitude of impulse, because F is the same on both. T will be the same. The time duration of the force experienced by A and B will be the same. Therefore, both will have the same impulse, same magnitude of impulse, exactly the same magnitude of impulse in opposite direction. That is, both will have the same magnitude of change in momentum. That will be in opposite direction. You must know these things related to momentum. Okay, so the data given in the question, I put it on diagram. We don't know the initial velocities of P, but the velocity of P is not given, but the speed of Q or velocity, they not specify the direction, so I can use the word speed instead of velocity. It's given to you, the speed of Q before collision, speed of P is not given. During collision, the question says that immediately before the collision, the speed of Q is 2u. The mass of Q is 3m and the magnitude of the impulse exerted by P on Q during collision is 4mu. So I already explained. So the impulse exerted by Q on P also will be 4mu. The direction of the impulse during collision experienced by Q will be towards right. According to my diagram, I took Q is moving towards left during collision. So Q will experience force this way. If you draw the force diagram, P is going to exert force on Q, that direction. So the direction of the impulse of Q or on Q will be towards right. Change in momentum of Q also will be towards right. The question A part, find the speed of Q immediately after collision. So here we are going to use the impulse that is equal to change in momentum mv minus mu for Q. That will be towards right. I know that it's going to be towards right, so I put it towards right. That will be towards right. Impulse on Q will be towards right. So that is 4mu. So 4mu is equal to mass of Q, that is that mass of Q, 3m, times the final velocity. I took it towards right, so v2. This minus sign comes here. This mass again 3m, I am writing for the particle or the sphere Q, that mass is 3m. The initial velocity according to this diagram is moving towards left. So that is opposite to the direction of impulse, because I know the impulse is towards right, but velocity before collision is towards left. So that is going to be minus 2u. Okay, solve this one. You will get 4mu equal 3av2 plus 6mu. That means all the a will get cancelled, is it? So make the v2 subject. You will get v2 is equal to minus 2 by 3u. Right? I am getting minus sign. I don't need to worry about it. Minus sign I am getting because it's a velocities. These all are velocities. Impulse, change in momentum, they are all related to vectors, right? So the velocity of Q after collision is 2 by 3u, which minus sign. I took it towards right after collision. When I took after collision, it is positive. I took it as the velocity after collision for Q is towards right. And I used the same sign because towards right I took it. So here I took the impulse on Q is towards right and the velocity I took towards right. So that's the reason when I take this one towards right, I substituted V2 positive. When I solve it, I am getting negative, means the direction is not towards right. What I took is not correct. It must be towards left. So minus 2 by 3u towards right. But when I take it, it should be towards left because minus sign 2 by 3u towards left. But they are not asking about the direction, that is the next part. But anyway, since I minus sign I got it, I explained that. So the final answer V2, the numerical value, the speed is 2 by 3u. B part, the direction of Q immediately after collision. So they are asking about the sign now only. So you should say towards left, right you can't say because in this question they are not specifying which is moving towards left, which is moving towards right. But I can say before collision the sphere Q is moving towards left, after also towards left, that is both directions are the same. So you can say B answer, the direction they are asking, same direction as initial velocity. The direction after collision is same as the direction before collision. The velocity of Q after collision has the same direction as before collision. You can tell that B. Okay, I am not writing it. You should say there is no change in velocity of Q, or you can say the velocity of Q remains the same as earlier. Whatever it is, both are the after collision, before collision, same direction. Okay, second question based on equations of motion. Better know the equations of motion. Uh, we can use the equations of motion under two conditions. First condition, the object should have or object must have a constant acceleration. First condition. Second condition, the object must move on a straight line. Okay, so there you know the overall equation. I can say A equal V minus U over T. That's the definition of acceleration. From that, if you multiply AT and make a V subject. Okay, so cross multiply. From this you can say AT equal V minus U. So V equal U plus AT. So you should be able to interpret this in terms of motion. That means the meaning of this equation. Initially, that means when t equals 0, if the velocity is u, when you substitute t equals 0, you will get v equal u. That means initially, if the velocity of the object is u, to substitute t equals 0, you will get v equal u plus 0, that is v equal u, is it? So when t equal 0, the velocity is u. Later, at time t, the object has an acceleration A, uniform acceleration. Later at time t is given by v equal u plus at. So you will find the velocity later at time t if you know the velocity when t equals 0. So this is the first equation we are going to use in the equations of motion. So the first equation, v equal u plus at, and you must know the meaning, how to use the equation, and you should be able to interpret it in terms of motion, right? I already told that. Okay, the second one, I told that these equations are valid only when the object moves at constant acceleration. So when an object has constant acceleration, its average velocity, say an object is moving from this point, it would have started its motion somewhere else, but when it reaches the point P, its velocity is u. When it reaches the point Q, its velocity is v. Means what is its average velocity when it moves from P to Q? So the time duration from P to Q, if it is t, what's the average velocity during the time t is given by, that is average velocity is given by u plus v by 2 is the average velocity. We can find u plus v by 2 only when the object has uniform acceleration, right? So the displacement from P to Q, the displacement, it moved from P to Q during the time t when its velocity uniformly accelerates from u to v. The displacement is given by average velocity into time, that is u plus v by 2 into t. That means the meaning of it, when t equals 0, so I am considering the time duration from P to Q. So here only the time is starting. When the t equals 0, its velocity is u. When time t equal t at later, the velocity is v. So the displacement during that time is given by s equal u plus v by 2 into t. Right. Now by combining these two equations, I can get the next equation by eliminating either u or v. By substituting here, I can get it. So if I substitute the third equation, if I substitute instead of v, if I substitute u plus at, s equal u plus, instead of v, I can substitute u plus at over 2 into t. That you solve it, you will get ut plus half at squared. So how to interpret this equation? The meaning of this is, when t equals 0, initially the velocity should be equal to u. Then at that moment no displacement. Later at time t, the displacement during the time t. So that means if I consider the portion from point P to Q, so when it moves from P to Q, at point P we are starting the measurement of time. So that time t equals 0. This time is t equal t, later t. The velocity here is v, the velocity here is u, the displacement is s. So the time duration is t. So the displacement during the time t from P to Q is given by s equal ut plus half at squared. Okay, I can get s in terms of v also. That means I can eliminate u by substituting u equal v minus at. There also I can get an equation in terms of for the displacement. So there I can write s equal instead of u I am going to substitute v minus at plus v over 2 into t. So that will be Vt minus half At squared. Okay. So in this equation, what's the meaning of it? We don't consider its initial position. Say maybe the object is at P1, its velocity may be u. Then at point P2, its velocity may be u1. Later at point P3, its velocity is v. So that means the time duration, whatever I consider here, then during the last time duration, at time t, if the velocity is v, the displacement during that time is given by s equal vt minus half at squared. So careful when you are using this equation. Okay, so students sometimes have confusion how to use these two equations. Now s equal ut plus half at square means initially when t equals 0, if the speed is u, then later during the time t, the displacement is s given by s equal ut plus half at squared. Okay, where to use this equation? We can use this equation like this. If we know the speed v at an instant, at a particular instant, if we know the speed v, before that speed achieved during the time t, before that speed is achieved during the time t, the displacement is given by s equal vt minus half at square. This is initially when t equals 0 if the speed is u. Later from that speed u, initially when t equals 0 the speed is u. Then from that speed u, later during the time t, the displacement is given by s equal ut plus half at square. Again, this equation we use, if we know the speed v at an instant, right? Now, before that speed during the time t, the displacement is given by s equal vt minus half at square. I can use this as an example. An object is moving uniform acceleration 4 meters per second squared from point P1 to P3. So it has uniform acceleration. At P1, when time t equals 0, t equals 0 means initially we consider, at that time t equals 0, the speed is 2. Then at time t equal 3 seconds, the speed is 14. You can substitute at v equal u plus at, you will get 14. For example, v equal u plus at, if you substitute u equal 0, u equal 2, a equal 4, the time is 3 seconds, so 4 into 3, 12 plus 2, 14, that's right. So that's the way it's calculated. Then later at time t equals 6 seconds, the speed is 26, or velocity is 26 meter per second. Okay, so if I want to find the displacement during the last 3 seconds, even if I don't know this speed, even if I don't know the speed 14 meter per second, I can find the displacement during the last 3 seconds. That is from 3 seconds to 6 seconds. If I want to find the displacement, there I can use this equation to find the displacement even when I don't know the speed 14 meter per second. I can use like this, s equal vt minus half at squared. So I'm going to find the displacement during the last 3 seconds of its motion. I can use this equation even when I don't know the speed at 3 seconds. So the final speed is 26 into the time duration from P2 to P3 is 3 seconds, because this is 6 seconds, this is 3 seconds. The time duration is 3 seconds. 26 minus 3 minus half into acceleration A, 4 into 3 squared. So we will get 60 meter. So if I want to use this equation, say for example a question says a car is passing a point P1 at 2 meter per second and its uniform acceleration is 4 meter per second squared, and it travels for 6 seconds and the final speed, it could be a first question, find the final speed at 6 seconds. You can use V equal U plus AT, the U is 2 meter per second, A 4, the time T 6 you put, you will get the 26 meter per second. Right, next question they are asking, find the displacement during the last 3 seconds. So there you can't use this equation because I don't know during the last 3 seconds when they ask, if I don't know this velocity at the third second, what is the velocity? If I don't know, I can't use this equation because I don't know the u for that velocity when t equal 3 seconds. So in that situation I can use s equal vt minus half at squared. Okay, so that's the advantage of using this equation to find the displacement during the last certain time interval. If I know the speed finally, then during the last time until it reaches this speed, during the last time t to find the displacement, we use s equal vt minus half at squared. This equation we use to find, if I know the initial speed u at an instant, later from that speed later during the time, that speed later time t to find the displacement, I use this one. This is if I know the speed at a particular instant, before that speed during the time t, what could be the displacement, we use this equation. I hope you understood where to use which equation. So there's another equation, v squared equal u squared plus 2as. So that is easy to interpret. If the velocity at an instant initially at a particular time, so here we are not considering any time here. So at a particular instant the velocity is u, later the velocity is v, it has uniform acceleration a. So the displacement of the object when the velocity changes from u to v, the displacement of the object when the velocity changes from u to v is s, which is given by v squared equal u squared plus 2as. Okay. Right, now we'll go to the question number 2. So a motorbike is moving with constant acceleration along a straight horizontal road. The motorbike passes a point P and 10 seconds later passes a point Q. The speed of the motorbike as it passes Q is 28 meter per second. Okay, we'll show it on a diagram. That's easily better. It's not necessary, but I'm just showing on a diagram. So this is point P, this is point Q. When it passes point P, the motorbike, I'll show the motorbike like a particle, its velocity we don't know, let it be u. Then it passes the point Q, the velocity is, the velocity at point Q is 28 meter per second. The acceleration is not given, but it has a uniform acceleration, is mentioned, and the distance between P to Q 220 meters. Okay. The question, find the acceleration of the motorbike. Okay, so I know the speed at an instant 28 meter per second. Before that instant, so the time here is given as, this is 10 seconds. This is 10 seconds after passing P. So when it passes P, if I take the time t equals 0, the time when it passes Q is 10 seconds, it's given in the question. So we know the speed at an instant and we know the displacement or the distance on a straight line traveled by the object before that speed achieved is 220 meter during the time of 10 seconds. So the question is, find the acceleration. So I can use this one. I can use the equation s equal vt minus half at squared, because if I use s equal ut plus half at squared, I should know the speed when t equals 0, then I should know the displacement after time t, that I know. After time t, 10 seconds, I know the displacement 220, but the u is not known. But if I use this equation, I know the speed at an instant, that is 10 seconds, I know the speed, which is 28 meter per second. Before achieving that speed, how much it traveled during the time of 10 seconds also I know. So I can use this equation to find the A. So we'll use A part S equal Vt minus half At squared 220 equal, the speed is 28 into 10 minus half into A into 10 squared. Solve it for A, everything you know that. So you know how to solve 220, this is 280, bring it to the left. So 50A squared equals, that's where you can solve it. So you will get 6 over 5 meter per second square, that is 1.2 meter per second square. Okay, so that's easy, but you might ask, can't we use S equal ut plus half At squared? No, that's actually unwantedly we'll get stuck, but we can use these two together. S equal u plus v by 2 we can use. So before that I should use this equation, because actually by combining these two I got it, but anyway sometimes students might ask, can't we use? So I'll show that way also. This is method 2, the same question. First use the equation v equal u plus at. So final speed we know 28 equal u we don't know plus a we don't know, a into 10. That is, we can say u is equal to 28 minus 10a. Now use the equation s equal ut plus half at squared, or you can use that simple s equal u plus v by 2, s equal u plus v by 2 into t. As we know 220 equal, instead of u substitute 28 minus 10a plus v, we know that 28 over t, that is t, that is 10, sorry, that 2, so not time 10, that 2 in t, t is 10. Okay, solve it. 28 plus 28, 56 divided by 2, that is 28, 5a. So 220 equal 28 into 10, 280 minus 10a divided by 2, 5, 5 into 50, minus 50. Okay, so that's going to be 50a is going to be 280 minus 220, 60. So a is equal to 6 over 5, same answer again. 6 over 5 means 1.2 meter per second square. Here we got the answer here also. Okay, so question number 2, B part. Find the distance traveled by the motorbike during the 5th second. During the 5th second means from the time 4 seconds to 5 seconds, that is during the 5th second. Okay, not the, sometimes you must misunderstood that distance traveled during 5 seconds. No, that is easy to find. This is during the 5th second. So during the 5th second means the time interval, just only for 1 second interval, that is from 4 seconds to 5 seconds. So if I take, this is the initial when t equals 0, at t equal 4 seconds, it has traveled this distance. I can say the distance traveled from here to here, initial point P2 at 4 seconds. If I say that as S4, then the time, the distance traveled during the 5 seconds from initial time, if I say this is S5, the question is during the 5th second, that 1 second interval, 4 seconds to 5 seconds, that during 1 second, it traveled from here to here. This is the distance, the question S. How much it moved? So S is equal to S5 minus S4. Okay, so here I think it's easy to use S equal ut plus half At squared, because we have find the acceleration already in the first part, 1.2 meter per second square, and we know the speed at 10 seconds that has taken as final speed. By using v equal u plus at, we can find the u when t equals 0, we'll find it. So use v equal u plus at. So v is 28. We need to find the u. Acceleration 4. Acceleration we already found it. So I'll put that value because what we calculated in the previous part. Acceleration is 1.2 meter per second square. We calculated it. So acceleration 1.2 into the time duration from P to Q. If I consider from P to Q, I am considering the motion into 10. So solve it and find the U, that is 28 minus 12, 16 meter per second. So I know the U, right? So we'll find what could be the displacement during the first 4 seconds, first 5 seconds, subtract. That's all, easy. So then we'll consider for the first 4 seconds, S equal ut plus half at squared, that is S4. The speed U, I found it 16 into 4 plus half into acceleration 1.2 into 4 squared. Find it S4. So you will get S4 will be equal to 73.6 meters. Okay, then we'll use for the 5 seconds, first 5 seconds. So S equal ut plus half at squared for 5 seconds from the initial move, from the point P onwards. So that is S5 is equal to the same initial speed, that is 16 into the time is 5 plus half into acceleration 1.2 into 5 squared. So S5 you will get it 95 meters. Now the question is the distance moved during the 5th seconds. During the 5th seconds means from 4 seconds to 5 seconds. That during 1 second interval. So distance moved during the 5th seconds equal S. So S is going to be S5 minus S4. S5 is 95 minus 73.6. So the answer will be 21.4. Okay, so here I used S equal ut plus half at squares. Normally students could ask, can't we use S equal Vt minus half at squared? Yes, you can use. So if you are using that, we should consider, anyway we want this displacement from 4 seconds to 5, this interval we need to find it. But if you are using S equal Vt minus half at squared, I told that if you know the speed at a particular instant, before that instant during time t, what's the distance traveled is the S. Okay, so there we could find like this. So here I'll raise this. So here this S4 and S5 I'm going to raise it. So there what we are going to do, we are going to find the displacement during the last 6 seconds, is it? So up to here, from after passing P, until this point it spent 4 seconds. Then it's spending 6 seconds to reach the point Q. So we are going to use that equation S equal Vt minus half at squared. For during the 6 seconds interval, it's going to travel from here to here. During the 6 seconds interval, it's going to travel from here to here. I'll put as S6. During the 6 second interval, from time 4 seconds to 10 seconds, it's going to travel this one, S6. Then I'm going to find the distance during the last 5 seconds. So I'm going to put this as S5. S5. During the last 5 seconds, it's traveling this distance S5. So during the last 6 seconds, it's traveling from this point to this point, because until this point, it traveled 4 seconds already. So this equation is something related to during the last time duration. This is after particular time. This is if I know the speed at an instant. Before that speed, during time t, the displacement. So I know the speed at 10 seconds 28. Before that, during the last 6 seconds, the distance traveled is S6. If I know the speed at Q, which is 28, before that, during the 5 seconds the distance traveled S5. So S5 minus S6 minus S5 is the question but they asked during the time interval 4th second to 5 second or during the 5th second. Okay, we'll try that way. We'll get the same answer. Okay, so I can say during the last 6 seconds. So S6 I will use S equal Vt minus half Kt square, that is S6 equal final speed anyway 28 times 6. During the time t 6 minus half into A 1.2 into 6 square. So you will get 146.4 meters. Then during last 5 seconds, S5 equal 28 into 5 minus half into 1.2 5 square. So that's going to be 125 meters. Okay, so we need to find during the 5th seconds or during 4 seconds to 5 seconds. So the distance traveled during 5th second equal S6 minus S5. So S6 is 146.4 minus 125. That will be 21.4. So same answer as earlier also, we got the same answer. Okay, so here the question number 3, a tractor of mass 6 ton, 1 ton is 1000 kilograms, so it will be 6000, the mass will be 6000 kilogram, 1 ton is 1000 kilogram. A tractor of mass 6 tons is dragging a large block of mass 2 tons along rough horizontal ground. The cable connecting the tractor to the block is horizontal and parallel to the direction of motion. The cable is modeled as being a light inextensible. Inextensible means it won't extend, so that's the big part. If it is extensible, during that extension, the acceleration could be different. But if it is inextensible, both tractor and the block will have the same acceleration, right? That's our answer B, but I told now, both will have the same acceleration. That means the string must be inextensible. The driving force of the tractor is 7400 newtons. So I put all those information on the diagram. So this is the tractor, the driving force 7400 newton, which is the friction provided by the tire, between the tire and the ground. Anyway, we don't need that, that's physics. But anyway, I put it as a force 7400 newton, that is the driving force. And the tractor has total friction force of 200 newton is given there. The resistance to the motion of the block is R newton. So this is the block, it has resistance R newton. If you want, I can put N also, the unit also I can include it, R newton. Okay, the tension on the cable is 6000 newton. So normally when we are showing the cable, normally we mark the tension like this. Here 6000 tension, we can put value later T. Here this is T. But students have wrong idea. They think the value, what I mark the arrow is the force acting on the string. No, it's the force acting on this tension, is the force acting on the third lobe pair, of the force acting on the tractor, and this is the tension on the block. Because imagine if there's a string, and if the tension acting on the string is marked like this. If I mark the tension on the string like this, what will happen? The string will sag. If you take a string and apply force opposite, the string will sag actually. So actually on the string, the tension must be marked like this. So if you want, I can draw again. This is the tractor. I'll draw everything separately. This is the string and this is the block. Right? There's the box. Okay, so what happens? They are saying there's 6,000 Newton tension on the string. Means the string should have the tension this way. This is T, I'll mark it, value I'll put it later, 6,000. So the string should have tension on both sides, same. If the string is light. If the string has mass, there will be acceleration. So F equal ma, when you consider, the tension will be different if the string has mass, but here it's saying light. Light means the tension must be same, because if I take this is T1, T2, what will happen? T1 minus T2, if I consider F equal ma, T1 minus T2 is equal to ma. Mass is 0 because light string into A, that is 0. So T1 minus T2 equal 0 means T1 equal T2. So if it is a light string, the tension must be the same. But if the string has a reasonable mass, then the tensions will be different. So I'll put the tension same TT. Okay. So now this is the actual tension acting on the string. It should be stretching the string. Tension always stretches. It won't compress. So this is the wrong diagram. Okay. What we mark here are the forces acting on the tractor and the box. I'll show that. Now the string has the tension like this. So this tension is provided by the tractor. So you know that every action has equal and opposite reaction. That is the Newton's third law. So this force is provided by the tractor on the string. So string will exert force on the tractor opposite way. So what I marked this arrow to the left is, here is the tension, the third law pair of the tension acting on the tractor. Same way, the string is pulling the box. So box is exerting this tension on the string. So string is exerting tension on the box this way to the right. So what I marked here is the third law pair of the tension acting on the box. So careful, these two arrows, they don't indicate the forces acting on the string. They are showing the third law pair of the tension, Newton's third law pair of the tension, which is the force acting on the tractor and the force acting on the block. Both are, these tensions are the same. They should have the same magnitude. Keep it in mind. Anyway, not necessary, but sometimes students get confusion. These are the reasons students, they say normally mechanics is hard, because when they don't understand the actual physics principles, sometimes mechanics might, you might feel the mechanics hard. Okay, now simple. The question is, find the value of R. Okay, so for that, we can use F equal ma. So for the tractor, we'll use this direction, we use F equal ma. The reason why am I using F equal ma not for the box first, because I know the tension, but we don't know the acceleration is unknown. So if I use it for the box only, it will become T minus R. T is 6,000 minus R equal 2,000 into A. If I write it for the box, it will become T minus, that is T is anyway 6,000. The tension, so 6,000 minus R equal the mass of the box 2,000 times A. Then problem, because there are two unknowns. So that's the reason I am not using F equal ma for the box alone. I am not using F equal ma for the whole system also. The reason, we don't know R, we don't know A. But if I use F equal ma for the tractor alone, I can find, because they are the only one unknown, that is A. So that's actually you have to decide for which object should I use F equal ma. Should I use it for one of the objects or to the system together? Yes, you decide it, because depending on the unknowns, right? So here I am using F equal ma for the tractor. You know the reason, because I can't use it for this alone. There will be two unknowns. Okay, if I consider the force, the resultant force I need, that is 7,400 minus 200 minus tension, that is tension is equal to 6,000. So minus T I should put, but instead of putting minus T, tension is given 6,000 equal mass of the tractor is also 6,000 kilograms. 6 tons, 1 ton is 6,000 kilograms, 6,000 times A. Okay, everything I know here. So I can find the A, solve it, you will get the A. That will be 0.2 meter per second square. That's the acceleration of the tractor. Means the box also should have the same acceleration because it's an inextensible string. Okay, now use F equal ma for the box. Box or block, they are using block, yeah. So that is tension T minus R. So T minus R equal ma. So T, we know that 6,000 given. We need to find the R. Mass is 2,000 kilogram times acceleration 0.2. Find the R. We will get 5,600 Newton. That's the answer. Okay, so only thing, the problem here, you need to decide for which object we are going to use the F equal ma, because there could be, if there are more than one unknown, you need to get two equations, and sorry, you can do it, but I just did it first for the tractor. Okay, question number 4, it's under condition for equilibrium. The resultant force must be equal to 0 in any direction. So if an object is at equilibrium, two conditions must be satisfied. That first condition, the resultant force in any direction. That means if you resolve all the forces acting on the object to any direction, in that direction the resultant force must be equal to 0. Right. Second condition, moment. About any point when you take moment, it must be equal to 0. Or turning effect must be equal to 0. So in certain questions, we don't need to consider the moment. But certain questions, we need to consider the moment. So this question, we are going to consider only the resultant force in any direction equal to 0. But here also, if you take moment, it must be 0, but we are not going to consider the moment here because the object is considered as a particle. But if the object is given with a well-defined dimensions, there sometimes we need to consider the moment also. So always remember that if an object is at equilibrium, both conditions must be 0. Resultant force in any direction must be equal to 0. Turning effect about any point must be equal to 0. Okay, so a small block of mass 5 kg lies at rest on a rough horizontal plane. Coefficient of friction between the block and the plane is 7/3, that is mu 7/3. Force of magnitude P newtons is applied to the block in a direction which makes an angle 30 degree. The block is modeled as a particle. Given that P equal 14, so that is 14 Newton is this force. Find the magnitude of the frictional force exerted on the block by the plane and describe what happens to the block, justifying your answer. Okay, we don't know whether block is at limiting equilibrium. Okay, we'll find. So for that, the situation is, we don't know. The question is, find the magnitude of the frictional force exerted on the block by the plane and describe what happens to the block, justifying your answer. Okay, so in this question, okay, so you should know the meaning of limiting friction and the friction. Say for example, when object is kept on a floor, a block is kept on a floor, and let it be its mass is m, right? It's a rough floor, it's a rough surface. Okay, initially it's at rest, so the weight balances the normal reaction, is it? And there are no horizontal forces. Now you apply a force, you pull that object with a force F. When you apply force F, for example, I'm just taking, for example, you're applying a force of 10 Newton. The block is not moving, it's still at rest. Means there is friction, the friction is 10 Newton. The friction is 10 Newton. Now you are increasing, Fr stands for friction, you are increasing the force that you apply to 13 Newton. Yes, still it's at rest, not moving. Means the resultant force equal to 0. Now the friction has increased to 13 Newton. Now now you are increasing this force that we are applying to 15 Newton. Still it's not moving. So the friction will increase to 15 Newton. Now you are applying a force to 17 Newton. That means it's about to move. About to move. That means if you apply little more than 17 Newton, it will move. But still the friction will be there. So when you apply a force of 17 Newton, it's almost starting to move, but not moving. It's about to move, about to slip means that friction is called the limiting friction. So limiting friction is the maximum friction between the two contact surfaces. Understand? So otherwise, until it reaches the limiting friction, always the friction will balance the force applied to it, as I explained. So when you apply 17 Newton, it's going to almost move. That means the limiting friction it has reached, that is 17 Newton. If you apply slightly more than 17 Newton, say if you apply 17.2 Newton, it will move, but the friction will remain at 17 Newton. That is the limiting friction, maximum friction. So until it reaches the limiting friction, the friction also will increase when the force is applied, as I explained. The limiting friction is given by Fr is equal to mu r, where mu is called coefficient of friction, r is the normal reaction between the two contact surfaces. Okay, so in this question, they are saying a force P is applied, that is 14 Newton. So P is 14 Newton, yes, at an angle 30. The mass of the block is given 5 kilograms. I'll show the forces. So mass means the weight is mg. So I'll substitute the value. M is 5. So m into 9.8 is the weight acting on it. There is friction acting, there is normal reaction acting R. Okay, the contact surface, there is a normal reaction. And there is a friction acting. But we don't know the friction. The question is, find the magnitude of the frictional force exerted on the block by the plane and describe what happens to the block. So they are not telling whether the block is moving or not. Okay, if the block is about to move, that means we can say it has reached limiting friction, where we can use F equal mu r. Otherwise, we can't use F equal mu r. If it is still at rest, it hasn't reached the limiting friction as I told, then the friction force must be equal to P cos 30. That is 14 cos 30 must be equal to friction until it reaches the limiting friction. Okay, so we'll see what could be the frictional force. So the maximum frictional force is the limiting friction. We'll find the maximum limiting friction. Maximum friction force, how much could it be? Right. So there we can say that means when 14 Newton is applied, still it's at rest means the force P is 14. Since it's at rest, any direction I told resultant force must be equal to 0. So if I resolve vertically, R plus P sin 30, P sin 30 means 14 sin 30 minus mg equal to 0. I'm going to find the limiting friction. The limiting friction is given by Fr equal mu. That is the maximum friction. It can't apply more than that. If the horizontal force becomes more than this, yes, it will move, right? Okay, so we'll find what could be the maximum friction. F equal mu r, we are going to use it. So that is r plus 14 sin 30 minus mass is 5 into 9.8 equals 0. So from this you will get R is equal to 42 Newton. So the maximum friction, Fr, friction, that is maximum. That's the limiting friction is equal to, I'll put the maximum as a subscription, Fr, the friction max equal to mu R. So Fr max is going to be, mu is 3 by 7 into 42, that will be 18 Newton. Right. So that is going to be 18 Newton. So if the total horizontal force could be only by the component of this one, because this is a vertical force. Vertical force has no horizontal component. When you resolve a vector through 90 degree, it won't have component. So this won't have horizontal component, this won't have horizontal, only this has the horizontal component. So if the horizontal component of this one, which is 14 cos 30, is greater than 18, it will accelerate or move to the right. Otherwise, it will remain at rest and friction will be lower than 18. Okay, we'll find the total horizontal component. So horizontal force FH, the horizontal force, equal 14 cos 30. So that will be 12.12 Newton. There's no other horizontal forces. So since the horizontal force, which is 12.12 Newton, is less than the maximum friction of 18 Newton, the friction will be 12.12, because I told that until it reaches the limiting friction, that is the maximum friction, when you increase the force, the friction also will increase. So the friction will be equal to 12.12 and it will keep the object at rest. Okay, so the second question, the value of P now changed so that the block is on the point of slipping along the plane. So that means they are not telling anything about the angle. So we should take the angle remaining the same, only the magnitude of P is changed. Find the value of P. Okay, now look at here. So here the friction, the maximum friction, they are saying it's point of slipping. So that means it has reached, the friction has become the limiting friction, but the limiting friction now won't be 18 Newton. Careful, here the limiting friction won't be 18 Newton. So the limiting friction is going to be something else here. The reason, we know that limiting friction is given by the limiting friction, that is Fr max is given by mu r, but mu is constant. That depends on the type of two contact surfaces. Earlier we found the limiting friction 18 Newton when the P was 14 Newton. But now the limiting friction won't be 18. The reason, anyway limiting friction given by Fr equal mu r, where mu is constant, which is given as 3 by 7. But R is going to change because R depends on P. R depends on P because the box is going to be slipped on the horizontal floor. The box is not going to accelerate up. So the resultant vertical force is going to be remain the same. So if I consider vertical direction, R plus P sine 30 minus mg equal to 0. Because when you change the P, the box or the block is going to be at limiting equilibrium. The question says about the point of slipping. So the friction would have reached the limiting friction. Limiting friction is given by mu r. R is not constant. R is not constant because R depends on P. Earlier this was 18. I want to tell again, the limiting friction is not 18 now. It will be something else. The reason R is changing because R is given by R equal mg. We know the mass, no change, but minus P sine 30. Sine 30 is half. Now you can see when you change the P, R is going to change. This is constant. Mg is constant. Sine 30 is constant. But you are changing the P. The P has changed, they are saying. So when the P is changed, R will change. When R changes, the limiting friction will change. So it won't be 18 now. Earlier P was 14 Newton. Yes, when the P was 14 Newton, the limiting friction was 18. Now it's going to be different. Okay. So sine 30 is half. So it's going to be mg minus P by 2. This is half. P by 2 is the normal reaction. Since it's at limiting equilibrium, when you consider horizontally, P cos 30 minus Fr max, we can say it's going to be about to slip. So there's a limiting friction. Fr max is equal to 0. But we know that Fr max equal mu r. So P cos 30 is root 3 by 2, e minus fr max mu r equal 0. Okay, we'll substitute that. Now everything I can substitute root 3 p by 2. So, or I can say root 3 by 2 p minus mu is 3 by 7. That remains the same. It depends only on the type of the surfaces. Instead of r, I can substitute mg minus p by 2. M is given 5 kilogram. So that is mg minus p by 2. That is 5 into 9.8 minus p by 2 equal to 0. So the only one unknown in this equation, that is a. So I'll continue here. So root 3 by 2 p is 0.87 p. Then 3 by 7 into 5 into 9.81, that will be 21. Then 3 by 7 into p by 2, that is 3p over 14, that is going to 0.21p equal to 0. So 0.87p plus 0.21p, that is 1.08p is equal to 21. P will be equal to 19.4 Newton. So that's the answer for the B part. Okay, so this question again on equilibrium. So here also resultant force must be equal to 0 in any direction when you resolve all the forces, but here only the forces acting up or down, so only one direction, either up or down, no horizontal forces, but here is a well-defined dimension, not a point object, so we have to use the condition, the moment about any point must be equal to 0. Even the previous question, where that question number 4 also, the moment is equal to 0, but we don't use it because we don't need it. That's the reason. Okay, so there's no question called question related to moment, question without moment, no, nothing. Condition for equilibrium means both conditions must be 0, so must be applied. Resultant force in any direction must be equal to 0, moment about any point must be 0. Sometimes we don't need to use the principle of moments depending on the question. Here we have to use it because the object has a well-defined dimension. Okay, anyway, so the uniform rod AB, uniform rod means the center of mass, the weight will act at the center of it. It's a 5 meter means, so the from A at 2.5 meter the weight, so this distance is going to be 2.5 meters. So from here to here, this is 2.5. So this is 2.5 meters. That means this is 1 meter, means this is going to be from center of mass, that normally center of mass is denoted by capital G, gravity, center of gravity. So this is 2.5, this is 1 means, anyway from this point which is named as C, this is C, this is point C, this is point D. From C to G will be 2.5 minus 1, that is going to be 1.5. This is 2, so this is 2.5, this is 2 means this is going to be 0.5. Anyway, simple, or even IGCSE questions, that type of questions where they are finding the distances. All the lengths are shown on the diagram, I shown it. Particle of mass 10 kilogram is placed on the rod at A, so 10 into G. So I put 10 G, not 10 gram, 10 into G, 10 into 9.8 is the force. At A they attached a particle of m kilogram, so m into G is the force, at B is acting on point B. Okay, so the rod remains horizontal and it's at equilibrium, at rest. Find in terms of m the magnitude of the reaction on the rod C. Okay, so here they asked to find the reaction on C, that is RC. The reaction on RD, the fulcrum or the knife edge, is RD. They asked to find the reaction on C. Okay, anyway, but here the condition again, total upward force must be equal to total downward force. That is vertically the resultant force must be 0. So RD plus RC equal to 10 into g plus 5 into g plus mg. That one equation. Then take moment about any point. You might get simultaneous equations in terms of RC and RD. But to avoid the simultaneous equation, I'm going to, it's a technique, I'm going to take moment about D, the advantage. They ask you to find the RC. So if I take moment about D, the perpendicular distance from D to D is 0. So in my equation, RD won't come in my equation. So it's a technique, right? So if I take moment about any point, it must be 0. I can take moment about any point, but I'm going to take about D to avoid or to eliminate RD in my equation. RD is the normal reaction from D. Okay, take moment about D. So A part, take moment about D. Okay, so B, I'll take clockwise moment, positive. So clockwise moment means about D, mg into the distance is 2, that will provide clockwise. This will provide anti-clockwise, this will provide clockwise. So plus RC into from D to C. So that is how much? This is 5, this is 2, this is 1, means from D to C, that's going to be 5 minus 3, that is 2. Okay, so this is clockwise, this also clockwise, this 2 will provide anti-clockwise. So minus 5 into G, 5G I will put it, 5G into 0.5, that is from D to G 0.5, because this is 2.5 minus 2, 0.5 minus 10G into this distance. So this distance will be total distance 5, total length 5 minus 2, that is 3, equal to 0. Okay, so that means solve it now. Okay, so that's going to be yeah, that's all. G will get cancelled. Anyway, they asked to find the reaction, so anyway we have to give the final answer in terms of G and M. So that's going to be 2RC is equal to, take to the right side, this is 30G. G is 9.81, okay, not gram, 9.8, but 30G. This if you take plus 2.5G, this one 2.5G, minus mg, 2mg. Okay, so that's going to be 30 plus 32.5G minus 2mg. Okay, for RC equals, sorry, now divide by 2, that's going to 16.25 minus mg, that's the RC. So B part, find in terms of M the magnitude of reaction on the rod D. So that means they asked to find the reaction on D. That is, we know that. So I don't need to take moment again. If you want, you can take moment about C, but better avoid it. So that we can say the total upward force equal total downward force, because it's at rest. So that is RC plus RD minus 10G minus 5G minus mg equals 0. Resultant force in vertical direction must be equal to 0. Okay, but instead of RC, I can put this one 16.25G if I substitute. That is going to be RD is equal to, take to the right side, 10G minus 5G. When you go to the right side, 15G minus RC, that is 16.25G plus mg, this mg also plus mg. So that's going to be 2mg minus mg plus mg, 2mg minus 16.25 minus 16.25, this one 1.25, that is the RD. Okay, so C part, hence or otherwise find the range of possible values of M. What do you understand by range of possible values of M? What could be the possible values of the range of values of M such that the rod remains at equilibrium? Okay, now look at it. It's that idea you need it. It's like this. Now we know the rod is kept on to support two fulcrums. So this is 1C, this is D, and there is a weight is acting here. That is weight is 5G, 5 into G. We put an extra weight here, that is 10G. There's an extra weight at B, that is mg. There are normal reactions RC and RD. Okay, it's simple actually. Now when you increase the M, you can push it here. Imagine if you push at the end B, what will happen? Slightly and gradually apply force here or increase the mg. Just push it here, gradually increase it. What will happen? The rod this side will try to topple, or it will tilt. Actually the rod will just lift from C, but it will be in contact with D. If you push this one here downwards, if you push the force at point B downward, or if you increase the mg gradually, what will happen? It will pull, it will be pushed this way. So at a particular weight of mg, the rod will slightly tilt and leave the point C. If you apply a little weight more than that, it will topple in clockwise direction about D. It will be in contact in D, but it will topple. So, but if you want to keep in equilibrium, it should not happen. That means always it should be in contact with C and D, even when you increase mg. So what could be the maximum value of mg such that the rod still in contact with C means when you increase the mg, it won't lose contact with D, it will lose first contact with C. Then from that moment, if you increase the mg slightly more, it will topple. So to keep it in equilibrium by increasing mg, mg has a limit such that the RC remains or equal to or greater than 0. That means RC, the contact force with C is greater than or equal to 0 means it's still in contact. It's still in contact. Okay. So RC should have a real positive value, means the rod is in contact with C, means it's at equilibrium, not toppling, even when you are increasing mg, but mg has a limit of force. So if I use that, RC must be greater than or equal to 0 means use this one. From this one, I should say this must be greater than or equal to 0 when you are increasing an mg. So mg has a maximum value such that RC becomes or remaining greater than or equal to 0. From that, I can find a limit of force for the mg. Okay, so I'll use that idea now. So in that situation, RC equal 16.25 G minus mg greater than or equal to 0 means mg less than or equal, take to the right side, so it will become positive. Mg less than or equal to 16.25 G, that means M should be less than or equal to 16.25 kilogram. That means you can't increase the M more than 16.25. If you increase it, this will lose the contact. So if you want to keep it in contact with that, you can't increase beyond. So that is the maximum value. Actually, that is the maximum value of M such that the rod is in equilibrium. Okay, so then we'll think about what could be the minimum value. So they asked me to find the range. Now look at here. Now this is at equilibrium. The rod is in equilibrium under 5 forces. What are the 5 forces? The extra weight applied at A, which is 10G, the normal reaction or the contact force at C, weight of the rod, contact force at D, and the mg. All these 5 forces keeping the rod at equilibrium. If I remove a force or if I reduce a force, it might lose, it won't be in equilibrium. Now look at here. If I reduce the mg gradually, imagine if I reduce the mg gradually, then what will happen? Beyond a particular force, when I reduce the mg gradually, beyond a particular force, if I reduce it beyond a particular value, the rod will topple about C. The rod will tilt in anti-clockwise direction. It will rotate and tilt in anti-clockwise direction. It will be in contact with C and it will lose the contact with D. If I reduce the mg gradually beyond a particular force, it will lose the contact with D and it will topple about C. But if I want to keep it in equilibrium, what could be the minimum force mg means? I should keep the D again in contact, means it should have a real positive value. Rd must be greater than or equal to 0. So Rd, we found it here. That means Rd must be greater than or equal to 0 means we can say Rd is equal to 2 mg minus 1.25 g, that it should be greater than 0 means bring it to the other side, and this is 2 mg, so that's going to be mg 2 mg greater than 1.25 g, so mg must be, g and g will get cancelled, m should be greater than or equal to, we can put greater than or equal, no problem, 1.25 divided by 2, that is going to be 0.625 kilogram. That means if the rod wants to be in equilibrium, we can't increase it beyond a particular value, which is 16.25 kilogram. If I increase, it will topple about D and lose contact with C. If I reduce the mg below 0.625 kilogram, it will topple about C and lose contact D. So to have equilibrium, the range of the mg must be, or range of the m should be such that m should be less than 16.25 kilogram, greater than or equal to 0.625 kilogram. That's the range of m to keep the rod is in equilibrium. Okay, so question number 6 on related to vectors. A particle P is moving with constant acceleration. Constant acceleration means the direction is not changing, it's moving on a straight line. Constant velocity also, no change in magnitude of the velocity as well as the direction remaining the same. Here the magnitude of the velocity, that is the speed will change, but the direction of motion will remain the same. That means the particle is moving on a straight line. Okay, a particle P moving with a constant acceleration. At time t equal 1 second, P has a velocity minus I plus 4j. I am just drawing a diagram. I am not following the exact values given. Just I am drawing a time. When time t equal 1 second, I draw it here, just here. Okay, t equal 1 second. The particle has a velocity that is u. We can say that is 4i minus I plus 4j. That's the direct. It's moving on a straight line. We'll take just a straight line. Taking just straight. I'm not following the velocities. I'm not considering anything. Just I want to show it's moving on a straight line. So that t equal 1 second. Then t equal 4 seconds. Its velocity v1 or v is equal to v1 is equal to 5i minus 8j. The question is, find the velocity at time t equal 3.5. Somewhere here t equal 3.5 means before that. What's the velocity? Let it be v. Okay, that's what we want to find it. So we know the u and v1. Okay, the acceleration is the same. It's moving on a straight line. So the acceleration is the same. So we know that the acceleration is given by a equal v minus u over t. So that is true throughout the motion, same acceleration. So if I find the acceleration by considering this velocity and this velocity at 4 seconds and 3 seconds interval, that will be same as when I consider the acceleration by using 4 seconds and 3.5 seconds also. Okay, so that means acceleration is equal to v minus u. So acceleration is equal to v. So I'll consider this one, 5i minus 8j. That's the velocity at 4 seconds minus velocity at 1 second, that is minus I plus 4j over the time taken. So 1 second to 4 seconds, that will be 3 seconds. So that's going to be, solve this one, you will get 2i minus 4j, 2i minus 4j meter per second squared. So when I consider, it's moving at constant acceleration. So when I consider the 2 points, this point and this point, that is at 3.5 seconds and 1 second, or at 4 seconds and 3.5 seconds, whatever the next 2 points I consider, if I calculate the acceleration, that also should be the same. So when I consider these 2 points, right, so the same acceleration, A is equal to, the final velocity is v1, that is 5i minus 8j, that is at 4 seconds, minus, the question is find the velocity, but speed means I need to find the magnitude of it, minus v over the time taken, 3.5 to 4. 4 is the latest, so v minus u is the v, I am going to find it, okay, that's v is the velocity at 3.5, divided by time is 0.5 seconds, that is equal to 2i minus 4, the same acceleration, constant acceleration, so 2i minus 4j, solve it, so 5i minus 8j, cross multiply, you will get, minus v is equal to, cross multiply, you will get I minus 2j, find the v, take it to the right, this is I minus 4i, so it's going to be, bring the v to the right and left, bring it this one, so that is 5i minus 8j minus I minus 2j, so that's going to be 4i minus 6j. The question is, find the speed, so speed at 3.5 or t equal 3.5, we need to find the magnitude of it, so square root of 4 squared plus minus 6 squared, so that will be 7.2 meter per second. Let's answer for question 6. Question number 7. Two small children, Ajas and Beth, are running a 100-meter race along straight horizontal road track. They both start from rest, leaving the start line at the same time. So if we consider the parallel tracks, so initially both were at the same position. So along the same line they are at t equal 0. So this is Ajas, this is Beth, right. Ajas accelerates at 0.8 meter per second squared. So A1 0.8 meter per second squared up to a speed of 4 meter per second. So he is running for 4 until the speed becomes 4 meter per second. 4 meter per second. And then maintains the speed until the crosses the finishing line. So the finish line is somewhere here. This is the finish line. So until he reaches the finish line, let it be time taken t, he is maintaining the same speed 4 meter per second. Beth accelerates at 1 meter per second squared. So greater than Ajas, so that is 1 meter per second squared. For time t seconds. So here the time is not given, for how long he is accelerating not given. So but they gave the velocity gained by Ajas 4 meter per second. But here they are telling he is accelerating for time t and he would have gained a velocity v1. And then maintain a constant speed until she crosses the finish line. Okay, so same speed v1, that speed also we don't know. both finish the line at the same time. So that means they are starting at same time, they are finishing at the same time. T equal T, right? Okay, they are finishing at the same time. T equal T will make it, right? Okay. Or we can say the time they took to finish. This is T2. They both take the same time. T2 will name it like this. We'll say the Ajas is accelerating the time when he gained the velocity v1, let it be t1. We don't know how long. That is v time t1. His velocity becomes v 4 meter per second. It's not given the time. We'll take it as t1. Sketch on the same axis the speed time graph for each child from the instant when they leave the start line to the instant they cross the finish line. So you should know the properties of the speed time graph, velocity time graph. The main difference between speed time graph and velocity time graph. Speed is a scalar quantity, so it will be always on the positive axis. Velocity is a vector quantity, so the graph could be either on positive axis or negative axis. But generally we can say the speed time graph properties, the gradient or the slope of the graph gives the acceleration, area covered by the graph and the time axis. Normally we say area under the graph. Area covered by the graph and the time axis gives the distance moved. Both are traveling same distance 100 meters during the same time. So the graph is going to start for both graphs going to start at the same time. Initially t equals 0, same point. Both graphs are going to end at the same time at time t2 because both are reaching the finishing line at the same time. Also, area covered by each graph must be equal to 100 meter. So that means they are traveling the same distance. So both graphs should have the same area under the graph that is equal to 100 meters. So if I draw for Ajas first, so the graph A part, they have to draw a speed time graph. Speed, so I can say v meter per second. So he is accelerating at 0.8 meter per second and gaining a velocity or speed of 4 meter per second. So straight line. So he is gaining a speed 4 meter per second. This is 4. The time we don't know how long he is accelerating, but we can find it. That acceleration is 0.8 meter per second square, and he is maintaining the same speed until he reaches the finishing line. So this time is t2. So area under this graph for Ajas must be equal to 100 meters. Right. Now for Beth, he is accelerating at 1 meter per second square. But he also should have the same area under the graph. So we know he has higher acceleration means the graph should be more steeper. So more steeper means I can draw the graph like I should draw the graph. It's a straight line because constant acceleration 1 meter per second square, which is greater than 0.8. So should I draw the graph up to here or should I go beyond 4 meter per second? Now remember that both are finishing at the same time. So he reaches a particular speed we don't know, but he is accelerating for time t. Then he also should move at constant velocity. So the area under the both graphs should be the same. Imagine if the black color graph, that is for Ajas, I drew it. That is for Ajas, A I name it. This is for Beth, I name it B, the blue color graph. If I extend the graph beyond above 4 meter per second, certainly the both areas won't be the same. But here they can be the same. They must be same, but they can be same. The reason, this is a common area for both. From the time t1 to t2 is a common area. Here the graph is greater gradient, means here the Beth is getting extra area here. That extra area here could be same as this extra area obtained by A. But if I draw the graph something like this, if I draw the graph something like this, about this one or equal to this one, if I extend up to 4 meter per second also, you know this area, the blue color graph will be greater than area under the black color graph for the Beth. It can't be more also. So the graph for Beth should have a lower velocity because both are reaching the final point at the same time, both are traveling the same distance, means area under the graph must be same. So for width, I should stop here and it goes this way. Now both will have the same velocity. This time is capital T. Okay, so we know the acceleration. So this is the graph we should draw. So this is for adjust, that is A. This is for bed, I name it B. Okay, second part, find the time taken by Ajaz to complete the race. Okay, so Ajaz or bed both are traveling for the same time. But the question is about Ajaz, that means this graph, I need to find it. So I know the gradient, that is 0.8. So gradient 0.8 is equal to 4 minus 0 over time t1, t1 minus 0. So find the time t1, that will be equal to 5 seconds. Okay, so find the area of this trapezium for Ajaz. Equal 100 meters. That is half into addition of the parallel sides 0 to t2, this length t2. That's a question, I need to find it. This length is t2 minus t1. This length is t2 minus t1, but t1 is 5. So t2 minus 5, that is t2 minus t1. This is t1. So this length is t2 minus t1. Into the vertical height is 4 equal 100. So from that 100 equal 2 into half into 4, 2 into 2t2 minus 5. Solve it for t2. You know that how to 50, you know solve to. That will become 27.5 seconds. So time taken by the other child also the same, because they are starting at the same time, they are finishing at the same time. But they asked for Ajaz, so the final answer 27.5 seconds. Next part, find the value of t for how long he is accelerating. That is the question. Find the time taken for t. So here we know that here also we need to use the area again. I'll erase this diagram. That diagram not necessary. Okay, so question number part C. The question is find the value of t, right? Okay, so this speed for bed, the speed gain at the end of acceleration during time t, let it be v1. Okay, so we know that acceleration is equal to, for bed I am writing, a is equal to v1 minus 0 over t, but we know the acceleration is 1 meter per second square, so that is 1. So v1 is equal to t. Okay, so area under the bed, the graph, the blue color graph, also 100 meters. So that is half into addition of the parallel side. So this length is t2, which is 27.5. Then this length, this upper length, that is t2 minus capital T, that is again plus 27.5 minus t, 27.5 minus t, that is this length. 27.5 is this t2 minus t, that means this length from here to here, into the vertical height, that is v1. But v1 is equal, into v1 I should put, but v1 is equal to t, so I'll put directly t here. Half into addition of the parallel sides into perpendicular distance to the parallel side. So perpendicular distance is v1, but I showed it v1 equal t, so into t equal 100. Okay, so we need to solve this. So half, that is going to be 27.5 plus 27, that is going to be 55 minus t into t equal 200. That is t squared minus 55t minus plus 200 equal to 0. It's a quadratic equation. Solve it by using calculator. You will get the value for t could be 51.08 seconds and whatever it is, that is 3.92 seconds. But this is wrong because the t that he accelerated before he reaches the finishing line. The total time taken to reach the finishing line is t2 27.5. So this answer, this time, the time of acceleration which is greater than finishing line never happened. So this is not an acceptable answer. So the final answer t is going to be 3.92 seconds, which is less than the total time he runs. Okay, so this starts. Okay, last part D, difference in speeds. So difference in speeds of the two children as they cross the final line. So for Ajas we know 4, only thing we need to find V1, but V1 is equal to T we found it 3.92. So D part, difference in speed equal 4 minus V1, but we know V1 is equal to T, we found it already, V1 equal T, so that is 4 minus 3.92, so the difference will be 0.80. Okay, question 8. It's on vectors. I did a complete revision related to vectors when I discussed October 2023 M1 paper at time. So there I'll give the link for the discussion of this paper in this video. So see the description of this video there. I'll give the link for this paper discussion, October 2023 M1 paper. There also go to the description of that video. They are at time 27:08, the time before discussing question 4. In that paper, question 4 is something related to vectors. So before discussing question 4 in October 2023 M1 paper, I did a brief revision related to vectors. So go through it if you have difficulties before watching this question. Okay, question 8. The two boats P and Q are moving with constant velocities. So their direction will remain the same because they are moving at constant velocities. Velocity of P is 15I. That means, you know, in the Cartesian coordinates, velocity of P. So if you think about the Cartesian coordinates, velocity of P, this is I, this is J. So velocity of P is along this direction, 15I, no J component. So it's moving horizontally. Velocity of Q is 20I minus 20J. So velocity of Q is 20I minus 20J means along I direction the component is 20. Along J direction in downward direction, that is towards south, because they are defining the IJ vectors. The question I is along the east and J is along north, means minus J along south. So this is 20 minus J, this is 20 meter per second. So we know the resultant velocity will be bisected because both components are same, so it will be along this direction. So when you think about vectors theta, so tan theta is going to be opposite 20 over 20. So from this theta will be 45 degree. The A part question, find the direction in which Q is traveling. Your answer should be in bearing. Bearing means the angle measured from north in clockwise direction. It should be measured in degree. So that means from north. So if I extend this line from north in clockwise direction in degree, this is the bearing. So the angle of bearing, A part I am answering. So bearing in angle is equal to, this is 90 degree theta, so 90 plus theta, that is 90 plus 45, So bearing is going to be 135 degree. That's answer for the A part. This is the resultant velocity we know along this direction. Okay, B part. The boats are modeled as particles at time t equals 0. P is at the origin, O and Q is at the point with position vector 200 j meters. So if I put it in coordinates, B part. So when t equals 0, this is I direction, this is I, this is j. So initially the P is here at the origin at time t equals 0. Q is at a point position 200 j. So along j at 200. This is Q at 200 when t equals 0. Okay. At time t seconds, the position vector of P is Pm and the position vector of Q is Qm. Show that PQ. Okay, so we know the velocity of P is already, we know that 15I. So at time t, later at time t, it will be at a position vector, initial position vector plus 15 into t. So it will be somewhere here. At time t, the P will be here, which is 15t. Along the I direction, because the velocity of P is 15. So you know the position vector to find, if I know the initial position vector, to find the position vector at time t later when it moves at constant velocity, it's given by initial position vector plus time into velocity vector. That means if I know the initial position vector P1, at time t later the position vector is given by P is equal to initial position vector. If I say AI plus Bj, that's initial position vector, plus velocity vector into time. That is the position vector at time t. See the explanation I given in October 2023 paper before discussing question 4. See the description of this video. I'll give the link for that paper discussion. There I explain all about these vectors. Okay, so this is the position vector of P at time t. So we know that Q is moving at 45 degree, bearing 135 is the bearing. So Q is going to move along this direction because velocity of Q is given 20I minus 20j. I already explained in the first part, A part. So it has velocity this way 20, this way 20 components, along this way at 45 degrees. So Q is going to move along this way. Okay, so at time t, the boat P are shown as particles, so it will be somewhere here, or we'll see that is somewhere here. If I take the P a little closer, that is 15t. The Q will be somewhere here. Right. Put it here. Easy to draw diagrams of the Q is somewhere here. Right, okay. So the question is, we need to find PQ vector. So what could be the position vector of P? That's given as P is equal to, initial position of P is 0. So that is the origin 0 plus 15I. So that is going to be 15I is the position vector of P at time t, 15ti. 15ti. Okay, at time t. Okay, what could be the position vector of Q? Q is equal to initial position vector 200j plus the velocity of Q into time. So that is 200j, that's a method, 200j plus velocity of Q is 20I minus 20j into t. So solve it, that's a position vector of Q at time t. So that will be So that will be 20 Ti plus 200 minus 20T. That's the position vector of Q. That is, position vector of Q means that is OQ. Vector OQ. All positions are measured about OQ. This is position vector P means that is OP. Vector OP. That's the position vector of P at time T. Okay, the question is find the PQ. So vector PQ we need to find it. So PQ we need to find it. This PQ means PO plus OQ. PQ, vector addition rule. Vector PQ is equal to vector PO plus OQ. So vector PQ is equal to vector PQ. That's a question they are asking. Vector PQ is equal to vector PO plus OQ. Vector PO is negative vector OP plus OQ. OP, that is OP, 15 Ti. OQ, 20 Ti plus 200 minus 20 T J. Solve it. That will be there's a mistake. Minus 15 minus OP means minus 15, right? So it's going to be 5 Ti minus 15 because its OP is minus OP. So minus OP is minus 59. So 5 Ti plus 20 Ti minus 15 Ti, 5 Ti plus 200 minus 20 T. This is a question they asked to show that. Yes, we got that. Right. Okay, so the next part, that is part C, find the bearing of P from Q at T equal 10. So we found the general equation for PQ in terms of time T. So that is D part. C part. At time T equal, when T equal 10, we will find the vector PQ. What could be the PQ? That is, substitute 10 here. 5 into 10I plus 200 minus 20 into 10J. So it's going to be 50I. So vector PQ is 50I. So vector PQ 50I means this is P, this is Q. If you draw the Cartesian again, but I can draw it again. So it's like this. If this is P, P is always moving on x-axis because its velocity only velocity is given as 15I, so it won't move to the j direction. So from P to Q, this is Q, the position vector relative to P, the position vector of Q is 50I. So this is, here, Q is here, 50I. 50I. The question is, find the bearing of P from Q. So from Q, if I want to find the bearing, so from north, this is the north. So from Q, I need to find the bearing of P, means I need to measure this angle, this one. So PQ becomes horizontal line along the y-axis because we got 50I. So bearing of P from Q means bearing always measured from north in clockwise direction. So from north, if I measure the angle, it should be this angle. So this is 270 degrees. Okay, so D part, find the distance between P and Q when Q is northeast of P. So okay, anyway, we know that P is going to move along x-axis because its velocity is 58I. So when P, this is I, this is J. So when P is here, find the distance of between P and Q when Q is northeast of P. So northeast. So northeast means from north at 45 degree towards east. So this is along the vertical line which indicates the north. Towards east means, so Q should be somewhere here. So this angle should be 45 degree. That means the vector PQ, this is a deep part. We are doing now deep part. Vector PQ, we found it the general equation, that is we got it 5ti plus 200 minus 20t j. That means along I direction the position vector is 5t, along j direction 200 minus 20t. So if I say this is along I direction in horizontal direction, normally we take horizontal, that is horizontal direction 5t, along j direction the position vector 200 minus 20t. This angle must be 45 degree because northeast. So we know that tan 45 is equal to 200 minus 20t over 5t. We know tan 45 is equal to 1, so that is 200 minus 20t equal to 5t. Solve it. For t you will get t is equal to 8. So this position occurs, the PQ, the position of Q relative to P becomes northeast when time becomes 8. The question is find the distance between P and Q at that moment. So the vector PQ becomes, when the time becomes 8, the vector PQ becomes 5 into 8i plus 200 minus 20 into 8j. So that will be 40i, 40i plus 40j. The question is distance, means the magnitude of PQ, the modulus of the PQ, square root of 40 square plus 40 square. That will be 40 root 2, or you can give it in decibel, 56.6 meters. That's the answer for the distance between P and Q when Q is at northeast relative to P. Okay, so the last part of this question, find the times when P and Q are 200 meter apart. Okay, so 200 meter apart means the modulus of this one should be 200. So that is mod PQ equal to square root of this 5t squared plus 200 minus 20t all being squared must be equal to 200. Okay, square it both sides. We will get 25 t squared plus here 200 squared minus plus 20t all in squared is 400t squared minus 8000 to AB, 8000t is equal to 200 squared 200 square will get cancelled. Rearrange it, you will get a equation finally. You will get 425 t square minus 8000 t equals 0. So t into 425 minus 425t minus 8000 equal to 0. So t could be one of the solutions 0. That's true initially. When t equals 0, p was at the origin, q was at 200j. So t equals 0, that's correct. Or the other answer 425 t minus 8000 equals 0. So t could be later. Initially they were 200 meter apart towards north. Q was at 200j meters given in the question. That's true at 0. So we are getting that answer. But the other answer, they'll again become 200 meter apart at 18.8 time. Second or, yeah, second should be, but anyway, 18.8. Okay. Okay, so that's all this paper discussion for vectors. If you want to go through the theory part, the brief revision I did when I discussed October 2023 paper, see the description of this video. The link will be given for that. In that video also see the description, the timestamps are given. So on the timestamp, the vector revision was done at 27.08 time. Okay, before question 4 I discussed it. Okay, right, bye.